Welcome. In this video, we are going to take a look at the Bohr radius for elements with Z protons. Okay, so we are going to start by equating the Coulomb force between the electron and the proton in the nucleus with the centripetal acceleration. So we will start with the sum of forces is ma. Here comes our Coulomb, right? So we've got K. Then the charge on the protons will be the number of them Z times Q sub P times the charge of the electron Q sub E. Remember, we use the magnitudes when we write coulombs. And we're going to divide by R sub n squared. This will be equal to the mass of the electron times V squared divided by R sub n. And this is because A sub C is V squared over R. And in this case, R sub n. Okay. And so we're using magnitudes. So let's set Q sub P equal to Q sub E. And so now we have K Z Q sub E squared over R sub n squared equals M sub E V squared over R sub n. Okay, now we're going to go solve, let's write it down, solve the angular momentum L, which is equal to M sub E times V times R sub n. That is equal to N times H over 2 pi. Let's solve that for V. Okay, so we just have to divide both sides by the M sub E and the R sub n. And so we get V is the N times the H over 2 pi, then M sub E times R sub n. Okay, now we're going to substitute that for V in our equation above. Okay, so we will say substitute. Okay, so we have the K, the Z, Q sub E squared over R sub n squared. This is equal to M sub E over R sub n. And now we have V squared. Our V is N times H over 2 pi M sub E R sub n. And we've got to square all that. Okay, so let's write that out squared. So we have the K, the Z, Q sub E squared over R sub n squared is equal to, we have an M sub E and R sub n. Now we have n squared, h squared, 2 squared is 4, then we've got pi squared, M sub E squared, R sub n squared. Okay, we can cancel one of the M sub E's. And we can cancel an R sub n squared. Okay. So this is going to give us K times Z times Q sub E squared equals. Okay, so we've got N squared, H squared. We've got an R sub n, 4 pi squared, and an M sub E. And now we want to solve for R sub n. Okay, let's multiply it by both sides. So we've got R sub n, then we've got our K, Z, Q sub E squared. On the other side, we've got our N squared, H squared over 4 pi squared M sub E. Note, those are all constants, except the N. We'll be able to let the N vary. All right, so now we need to divide by the K, the z and the q sub e, and let's write it this way. So we know that n squared can vary. We're dividing by z, that will vary, and now the rest will be constants. So we have the h squared, we've got 4 pi squared m sub e, and then we have the k and the q sub e squared, and we already took care of z. Okay, sorry about that, these are all constants. And so a sub b is going to be h squared over 4 pi squared times m sub e, k, that's Coulomb's constant, q sub e squared. Do that calculation, and we find a sub b is 0.529 times 10 to the minus 10 meters. This is our Bohr radius. And so what we have is r sub n is n squared divided by z, the number of protons, times the Bohr radius a sub b. I hope you found that helpful. Thank you for watching, and I'll see you in the next one.